Hello everyone. This time I will talk and show you how to properly create CI/CD pipelines on AWS using only AWS stack. So we'll not use anything else, just AWS stack in order to deploy Lambda function with Python code. So we will stay completely with serverless today. No servers will be included. So quite nice, I think. My name is Pawel. I am lead system engineer at IPAM Poland. Also, I'm DevOps Institute ambassador, and recently I become AWS community builder. So I think we can start then, right? How we understand CI/CD? For many people, unfortunately, CI/CD means they have Jenkins. They are wrong, of course. Jenkins is only the tool, one of the tools you can have inside your pipeline. And Jenkins is helping you to achieve the state where you can say that you have continuous integration, continuous delivery, or continuous deployment. But this is only one small element here, nothing else. So I'm doing a lot of technical interviews, and I strongly believe right now we have problem with CI/CD. What is really CI/CD? Where CI ends and CD starts? What is CD and what is the other CD? So let's reveal this for the for this specific talk and just to reveal this mystery. So we have CI, right? We have CD and we have another CD, and multiple people, as I said, has problem with defining the boundaries between them, and they are confused what we are talking about really, especially if we are talking about CD and CD. What is the difference between two of them? So simply, we have continuous integration, CI, and we have continuous delivery as one of the CDs, and second CD is continuous deployment. What we can define in all of them. So continuous integration is the first part where you have your CI/CD automated process. So we are talking about regular commits into the code repository, into version control. We are talking about unit tests. We are talking about building the artifacts and storing these artifacts, right? So the moment where you send your artifact somewhere, it can be Artifactory, it can be S3 on AWS, whatever. This is the boundary when CI ends. Right? Then we have continuous delivery. So this is, for example, automated tests on some specific environments. It's automated delivery of artifact. It's control what is delivered. Right? And I'm calling this one-click deployment because there is a moment when your pipeline, automatic pipeline, stops and waits for manual intervention. It can be review, it can be confirmation from release manager, whatever. There is a moment where your pipeline stops and waits for intervention from human being. And continuous deployment has only one change. It's automated installation of artifacts on production systems. So we don't have this one-click deployment, we have zero-click deployment. Seems simple, very simple and small difference, but this difference changed everything really, because here in one-click deployment, we have the moment where we can stop and think, hey, is everything okay? Are we ready to deploy this on production? In zero-click deployment, there is nothing like that. It's you commit, you have on production. So everything between those 2 points is done automatically. This is the tricky part, let's say. Example of CI, to understand it fully, completely from start to the end. We have commit, right? After commit, we have static code analysis, for example, SonarQube, whatever, right? We can do it after commit, we can do it during the pull request process, etc., etc. After static code analysis is done, we can do unit tests. After that, we are building artifact. We can test this artifact. Imagine, for example, that we are building container, Docker container. We can test this Docker container right now if this container is able to be executed and be stable, right? And we store this artifact somewhere. Artifactory, S3 bucket, local repository, no matter. Right? After that, we are going into CD process, and we start with this artifact. So we are collecting this artifact. We deploy to, for example, QA environment. We are doing tests, we deploy to release candidate, we are doing tests, right? We have this manual approval, and it's no matter how many and what is the name of the environments in the road. And after this manual approval, we have a deployment to production. And this is continuous delivery. Right now, it starts to be continuous deployment. Okay, this is this small difference between those two CDs. So today we will do something very simple, but hey, as we are experienced DevOps people, we do something simple in a very complicated way, because why not? Yeah? So we will deploy a very simple application which contains only two elements. The two elements is a Lambda function here, in here, and this Lambda function is behind the API gateway. This is only two things which we will deploy. And for this, we will use, obviously, Lambda function from AWS. We will use API gateway, those two elements which we will deploy. And for deployment of these two elements, we will use SAM CloudFormation model, CloudFormation deployment model. So SAM is the serverless application model from AWS, which allows you to define your stack, your Lambda function, control this Lambda function, set all needed resources for this Lambda function. For example, which programmatic language you will use. In our case, it will be Python. And also it allows you to create all needed or almost all needed resources for this Lambda function. In our case, we will create API gateway using this SAM model. We will use also CloudFormation to deploy this CI/CD stack. So it is totally automated and totally created as infrastructure as code project, right? So we have infrastructure as code for deploying CI/CD, which using infrastructure as code deploys Lambda function. So this is the beauty here. We are talking here about scalability, reliability, version control of this system, etc., 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 and obviously automation, right? We will use, excuse me, we'll use chain sets. So the deployment of Lambda function will be based on chain set. I will explain what it is in a second. We will use events. So every single commit to our repository to master branch will generate event, which will be consumed by code pipeline in order to be executed. We are using code commit to store our code. This is the only one element which is already created by me. We'll use code build twice for testing and creating the artifacts. We will use code deploy to, well, deploy our artifact into AWS environment. We will use simple notification service for one simple reason. Today we are building continuous delivery. This process here with SNS will inform us that pipeline is waiting for our approval or for our action. We will use, obviously, as we are talking about AWS, IAM roles, policies in order to allow our pipeline to create needed resources. And we will use S3 bucket where our Lambda function code will be stored temporarily during the deployment. If you think that is enough of icons and things, then I have bad news for you. It's not. We will have more icons here. So this is how our code pipeline will look. So using CloudFormation, we are deploying code pipeline. Code pipeline in this case is kind of a wrapper for and scheduler for multiple steps which we do inside this code pipeline. So we have code commit, and when any kind of commit is done to master branch, event is created, and this event triggers first code build, which is testing. We are doing unit tests, coverage tests, etc. After that, we are building our artifact and store this artifact in S3. And code deploy is executed after it. Code deploy use notification in order to send us the message that, hey, you have something waiting for you. And this code deploy deploys another CloudFormation template, SAM, which deploys API gateway and Lambda function. Simple like that, let's say. But code deploy is not only one block like I have here. So let's zoom in here to our block. This is how our code deploy looks like. So we have 3 steps. We are creating change sets, what means we are checking what is actually deployed and what is the change inside the project. We are creating this change set. Here we have manual approval step, which sends notification to user. In this case, it will be me, obviously. And here we can check what this change set has inside. So what was changed, really, right? And on the end, we are executing the change set. That's it. Why change set are so powerful? Let's say first, you'll see already what we can do with change set, right? Generally, when you have CloudFormation and you do update stack, it will update your stack. That's it. When we are creating change set, we are create the list what is new, what is changed, what is removed. And based on this, we can create event change log in our version control. We can self-document all changes by pushing this this list somewhere into the repository or documentation, whatever, right? So this gives you this control on top of the, let's say, technological process itself, right? So that's why this is very powerful. And also you can examine these change sets very deeply. So you really can understand what is inside and how it interact with your system, really. Right, so it's time, I think, to show you what we have. So let me first show you our repository. So I still have more than 15 minutes, so it's quite good for me. First, we will deploy this Lambda. Oh no, this is this. No, this one. Very simple function. This is our handler. This is how we construct Lambda function, right? And this Lambda function will do 4 mathematical operations like sum, division, etc., etc. And here we have 4 functions which are doing the job, really. And after that, we send it as a response back to our API, right? So this is Lambda function. This Lambda function is deployed using SAM template, which is here. We are saying here, this is the most important element here, transform. It means that when executed, CloudFormation will transform this very short template into proper CloudFormation stack, proper CloudFormation template with API defined, with all of these defined in separated resource sections. So it will be definitely longer and bigger template than this. Here we are saying very simple things like we want to use serverless, our handler, so this place which is executed when Lambda function is triggered is called handler, and my function is called simple function. Code is stored here. This is for the deployment process or even build process. So you see this directory here. This is it. Runtime, for runtime we are using Python 3.8. We are giving to our Lambda 128 megs of memory. timeout for our Lambda is 10 seconds. So if the execution will be longer, our Lambda will be timeouted. And here we are creating API, very simple, only one endpoint with get method. That's it. This Lambda function will be connected to this endpoint. So when I enter the endpoint API with this endpoint, I will execute my Lambda function. So this is the simplest part of it. Here we have infrastructure as code, so our template for the code pipeline. So as you can see, it's quite huge, right? We have a few information here which we need to pass to our Lambda file, to our stack, in order to be created properly. So here, first information, first variable, let's say, or parameter, is the email where the notification need to be sent, and what is the name of the repository where the code is stored. Of course, with this pipeline, you can create a code commit repository. It can be created by CI/CD, but for the example reasons, I have this repository already created. I have the code there, and that's why I need to pass this information to my CloudFormation. I'm creating artifacts. So one is, resources. So one is artifact bucket where I will store my Lambda function. This is the topic, not SNS topic for sending the notification. Bunch of roles, because roles and policies, because we need policies and roles for code pipeline itself, for code deploy, for Lambda function, and for executing everything here in process of creation stack for our Lambda function. So a lot of roles and policies. I'm scrolling it down, but on the end, you will see the link to the repository. You can go there, play with this, see what's going on there. And here we have our pipeline defined. Our pipeline contains 4 stages. First is pull source. This is obligatory. Code pipeline always need to have this stage. It means simple. We are getting code from the repository. It can be code commit like I have here. It can be GitHub, etc., etc. After that, we have test and coverage, and as you can see, this is code build. Third step is building the artifact also as a code build. And here we have the stage code called deploy Lambda, which is already set as a, where is it? As a deploy. Okay? So this is called deploy. And here we have 3 stages, really, 3 actions. We are creating change set. We are creating manual approval. And we are creating execute change set. And on the end of this template, or almost in the middle, we have the configuration of our stages, because this is like a skeleton of stages. Here we have configuration of stages. So for example, for Lambda test, which is here, you see, configuration of this project is in Lambda test section, and it is here. We are saying that this is our system on which we will build this this stage, and here is like a similar in almost all other CI/CD tools, declarative way of saying what we will do. In our case, we will test our Lambda function with Python 3.8, PyTest, and PyTest coverage. Right? Simple like that. Here we have second stage or second configuration for Lambda build for the second or third stage, really. And the most important element is here. Here we are using AWS CloudFormation package in order to pack our template from SAM framework and send it into S3 bucket. On the end, really on the end, we have the event created, and this event says if something will change on the branch called master in our repository, create an event. And this into this event, our code pipeline is registered, and simply speaking, code pipeline is listening if new event is created. If yes, then execute the pipeline. On the end, we have Code Guru. Code Guru is quite new service from AWS. It allows you to do two things. One, which I'm not using here, is Code Guru Profiler. It can help you to design your code better, let's say this simply. And Code Guru Reviewer can be used as an additional reviewer for your pull requests. And using machine learning, which is incorporated into Code Guru, it can give you advices what you should do with your code in order to have better code, let's say this way. Very powerful, very useful tool. In our case, where the Lambda function is simple like that, there is no advices what to do with it, because it's too simple. Okay, so we have this. Right now we can jump into our AWS console. And as you can see, of course, why not? I need to relog in. Give me a second. So what we will do, we will deploy our stack, and you will see what the stack will do when it is created. So to reveal a little bit, when I'm logging, it will create the code pipeline, and after creation, immediately it will execute it. So this is also a nice thing, because you don't need to care about that, right? So Lambda will be created just after code pipeline will be created. So this is a quite nice thing. Okay, so this is my window here. What I want to say, I want to show you, code pipeline is empty. I hope at least it is. Yes, there is nothing here. Okay, so let's see what we have in CloudFormation. Also empty. Perfect. As you can see, we don't have any stack. Right. So now it's time to do our deployment of our stack. And this is the only one manual step which we need to do, is to create the CloudFormation. Of course, always, no matter how automated environment you have, always there is some manual step on the beginning. There is no magic. It has to be. Right. So I'm using AWS CloudFormation. This is our service where we deploy our CloudFormation template with our pipeline. As I have multiple accounts, I need to use profile to pass proper credentials to proper environment, to proper account. In my case, I called my demo. And what I will do, I will create stack, and I will call this stack, let's say, something like that. Now, I have my template locally on my computer, so I need to pass this information into CloudFormation template, into CloudFormation execution. Of course, you can use also S3 here, so it doesn't really matter where you have this code. So what I need to do is template body, and I'm saying file. It means it is locally on my computer, and this file is in directory AIC, and it is called code pipeline YAML, right? That's not the end. This template is creating IAM policies and IAM roles. We need to pass the information to the CLI that we are aware of it, right? That's why we need to pass the parameter capabilities. And in our case, we are saying that we are aware that we are creating new resources in IAM. As you remember, I think we had two parameters in our CloudFormation template. Let's pass this the proper values for these parameters here. So we have parameters, of course, and right now this is like a not very nice way of doing this, but whatever. Parameter key in our case, it is notification and the value, as you can see, it's quite not nice way of doing this. And the value is, so you already know how to contact me. And we have a second parameter, so we need to repeat the step, and it was repository name and the parameter value is in our case CI/CD lambda. Right. Let me show it to you. This is it. We have it here, repositories. Yeah. CI/CD lambda, this is our repository, and this is the code which I showed you just before, right? All right, so let's try to execute it, and we'll see if I wrote everything correctly. And of course, no. All right, let's see. AWS Cloud Formation profile, create stack name, okay, template body, looks good. Looks good. So in order to not to wait too long, I will just copy proper command because I have it somewhere. So probably I have some typo or something like this. Yeah, we have the information that stack is under creation, and even we have the ARN of the stack. Let's see what our CloudFormation is doing. You see, our CloudFormation stack is in progress. We can see what's going on here. Just creating all stuff. In a second, I should receive an email from AWS. Even I already received it. I will show you that I need to subscribe to my topic, which was created. So yes, I clicked the yes, and I have this on my second window, so you do not see it. We need to wait like 1-2 minutes for having this created. And right now, here in code pipeline, we should start to see something. Yeah, code pipeline was created and already triggered. So let's see how our code pipeline looks like inside. Get source. The first stage, obligatory. We are collecting code. We are doing tests. Right now, the tests are in progress. So when they will be finished, I will show you how it looks. And here you have the indicators, how many stages you have and where you are with this. It is not perfect, I would say, because here you see right now you see only one run, because this is the first run. On the second run, you will see the state of previous run and current run. Can be misleading, let's say. Right, so as you can see, our test and coverage stage finished. So let's see what is inside. We have standard thing. We can see all commands, all logs from the stage, but the most interesting things are here. So we have all stages or sub-stages of this build process listed here. So you can, if something is wrong, you can check on which sub-stage or phase your build was failed. And we have also reports. We have two reports, really. We have unit test and we have coverage. So let's see both of them. As you can see, here I have my test cases. Honestly speaking, I created this test in that way that I multiply the test multiple times to have this bigger number than just 4. So you can see I have 20 unit tests and all are green, all passed, so we are good here. What you can see even, this is a really nice thing. This pipeline is executed for the first time, but I ran this multiple times before, and the reports are called exactly the same. That's why I see the history, right? I see the information, how many times I failed with the tests. I see the information, what is the duration of each execution. And based on this, I can measure my CI/CD, okay? Second, report is our code coverage summary. As you can see, I have 56 lines covered by test and 8 lines not covered. And this is information even where and what kind of coverage I have. I'm sure that right now our code pipeline went further. Right, so this is done. This is done. It's simple. We are creating the package and send it to S3. And here we have this 3 phases of our deploy stage, right? Create change set, manual approval, and execute change set. So we created the change set here. Let's see what is inside. And by the way, I received the email. Yes, I just show you this email. You see, I have the information where, what and where I need to do. So here I have information what is changed. In our case, obviously, everything changed because we are creating the stack. All right, so we have this and even more. We can see the same thing here in our stack list, that new stack is created. This stack is created by SIM model, which was transformed into proper CloudFormation, right? So let's see it. You remember that, that template is not visible right now. So we are in the review in progress state. So that means that we have our change set created. Yes, we have this change set. This change set covers exactly the same information, right? So it looks like okay. I'm pretty happy with that. I'm doing review, approve, and done. Right now, my change set here should disappear in a second. Yes. Why it happened? Because change set was executed. That's why this change set is no longer needed and is deleted. If there will be a problem, depends on the kind of the problem, the change set can stay with the status failed or something like that. Okay. Right now we are executing our change set. Let's see if we have template already. Yes. So here we can still see the template of the SIM. That's okay. It's changed then. Our Lambda is deploying. When we go to Lambda functions, we should see this Lambda already. Yeah, we have our Lambda function. It is here. We can even test it. Let's do a very simple test case. We don't need that. We just need brackets, save changes, and we can test it. Yes, you can see it was executed. Even now we can go into configuration. Not here, I think into configuration of the application itself. Here we have our endpoint. Let's use it. Oh. should work. Yeah, as you can see, I went through API. During the deployment, my API created this alias stage, whatever, called prod. So I can create multiple APIs or multiple stages of my API in order to test it before it reached production, right? So that was that simple, really. My pipeline is executed, everything is done. As we have limited time, so I will just stop here, and you can play with adding your changes into commits, create pull requests, see what code Guru reviewer is showing to you. And when you push your changes to master, it will automatically execute the pipeline, right? So this is the link to the repository. You can clone it, fork it, whatever you want. The easiest way is to keep it in code commit, but also you can configure GitHub for it. And I'll be happy to stay in touch. And that's it. Thank you very much. I hope it was informational for you. Thank you very much for your attention, and good luck with this Lambda function. Thank you very much.